Welcome to Focus Tutorials 2, Game and App Development students. In this tutorial, we're going to get some of the basic control building blocks of our project up and running in the second section. Remember back in our first Focus project, we got some basic movement going on for a player object using key inputs, referencing the input manager. In this set of tutorials, we're going to deal with inputs in a slightly different way. This time, rather than just manually moving the X and Y and Z positions, we're actually going to apply forces to our object to have physics do the action of movement rather than just manual transformations. So a slightly different approach. We're going to begin by creating a 3D plane. And I'm going to make this plane kind of long. So I'm just going to stretch it out and move it so I have a little bit of a road and try to center it in front of where the camera is. I just want to double check that I have a nice kind of view of this. So let me move this camera up and back and tilt it down. Oh, not that way. This way, camera. Tilt it down a little bit so that I can kind of see this road a little bit in a centered manner. Wonderful. Then I'm going to create a cube. Actually, let's go with something else. We'll see some things work a little bit cooler if we use a sphere in this tutorial. So I'm going to bring the sphere and notice that it kind of blends in a little bit too much with this white ground. So let's quickly recap how to make a set of materials. I'm going to make a first material and call this player material, and a second material. Let's call this one ground material. Let's make the ground material have a nice kind of grassy color. And let's make the player pop. Why don't we give it a nice fluorescent pink color this time around? So very clearly that player, and let's lift them up just a bit above the ground. And so we're going to get some of our basics for movement up and running nice and quick here. I have my sphere collider, my mesh renderer for the graphics. Remember, the sphere collider is responsible for physics interactions. We'll talk about collisions in a later tutorial in this section. Last thing we need for our physics to actually work in total is this rigid body. And let's just see what happens. When I press run, my ball should fall onto that surface. Nice. I like my colors in here. It's looking really good. So I have my player and ground materials. Now I can just make my folders to organize this. I'll save that for another time to keep this tutorial a bit shorter. And one thing that I want to do right away is rename my sphere to player and rename my plane, rename to ground. And now I want to create some prefabs from them, just so I have reference to these materials here. And I am going to actually leave these here for now because I might be messing with them with other materials in a few minutes. So what I want to do with my player is actually create a script. Let's create a player controller script, create an add in our way that we've learned so that it automatically builds, names, and attaches the script right off the bat. And I'm going to give my player some controls. So let's have this pop open here, player controller, and let's get this set up. Let's create a float for the speed. Let's create a public float for the horizontal input. Let's create a public float for the vertical input. And that might be all we need for now. We are going to just go into update. And we've done this all before for gathering our different axes. So I'm just going to copy and paste it from another file to save some time. A horizontal input is the value we got from the horizontal axis and the vertical input from the vertical axis. Awesome. In our previous tutorial series, what we did here was we actually did a transformation. And we actually changed the position of our object manually with some transformations. This time, we're going to do something a little bit different. And we're going to see how we can connect things together a little bit more easily in Unity. I'm going to be creating a rigid body component. And it's going to be private because I'm going to be getting this component in a slightly different way. I'm going to call this RB. I'm able to actually reference this class type rigid body. If we go back into our Unity project, I've attached a rigid body to my player, but nothing else in my world has a rigid body. They could, however. A rigid body is just a template for the rules of physics, and I can attach it to anything that I want. I could attach a rigid body to the ground. Let's just see what happens if I do. If I attach a rigid body, we're going to see something kind of odd happens, where now the ground has gravity applied to it and it falls into nothingness. I could turn off gravity and have a rigid body on it still, and then we'll see that they don't interact quite properly because there's actually some other settings that need to go on. There's no reason to have a rigid body on the ground. It's just kind of wasteful and bad for the processing speed of things. But I could have it if I wanted. So rigid bodies are kind of universal components that, if I need to, I can access. This is a reference to a rigid body that isn't instantiated yet, or I don't actually have access to something that exists in my world. How do I get access to it? I need to somehow get this component off of the thing my script's attached to. Excuse me. This rigid body is attached to my player. This script is also attached to my player. Because they're both attached to the same thing, they have nice direct access to one another through this method that we're going to get very familiar with called getComponent. The method looks like this, and we need to fill in a bit of information in these kind of triangular brackets. The information is the type of component we're attempting to snag, and I'm trying to snag a rigid body. By doing this, I'm actually snagging the rigid body of the object I'm attached to, or the script is attached to. So now I actually have access to this object, my player's rigid body, in my code. Meaning that now down here, I can actually run some behaviors on it. And in this case, the behavior that we're looking to work with is add force. Now notice we have explosion forces and force at position relative to torque, and torque forces for different types of physics interactions. For now, and for a lot of things that we do, add force will be the basics of what we actually want to worry about. So what am I going to add for force? Well, I need to add a vector 3 because I need to give the force some vector information or directionality. And in this case, I want for my vertical input to input, well, let's take a look at our scene here. What do we have? We have the autosave here. So why don't we do horizontal first? So horizontal, we're actually going to be going in our scene here on the x-axis. So that would mean that I need to actually apply a force on the x-axis. And if my experience serves me right, we should need a -1 here. And I'm also going to times this by the speed and the horizontal input, just like we did previously. Next, I'm going to add another force. And here, add a vector 3. And in this case, I want to move it vertical, so forward and backwards. And that on my scene here is the z-axis. So this would be 0, 0, and I think we need to go with +1 here. We'll see if my memory serves me right. And my vert input. So now I should be able to actually add force. Now, previously the only force that we've seen is in collisions, but we can manually create kind of a pseudo collision just by having this run here. And let's not forget to actually add in some speed so we see this in action. And let's see how well I did at actually predicting which numbers. Remember, trial and error might be useful here. So forward and back is working, but I'm noticing left and right is the wrong way. So I didn't actually need to do this. It all depends on which way you're facing. It would have to be the other way if I was facing the opposite way, of course. I just do trial and error until I get it right. It doesn't take very long. And let's see here. Left, right, forward, and back. And now notice that this ball kind of just keeps on rolling. It actually has a force applied to it. And I've placed no limitations on this force, so it can kind of get pretty fast. But, forward and back, and there we go. I got this nice rolling ball. Give this a try. Get a ball rolling on a surface, and in the next video, we'll do some more stuff with this.